rotting flesh. So even if they smelled it, they would think it was, was that you? Okay. So you had a question, didn't you?
Yes, I was going to ask about the hypercane bubble wrap deposits.
Yeah.
These larger ones, where are they found? In particular, what elevation, how high have they been found?
I think, and I wish I had better detail for that, I think they're found all over, geographically and geologically, that they're found in multiple, lots of different layers and all over the world. The ones I've seen in person, and this was not too long after these became somewhat popularized in the literature, were in the cliffs there at San Diego. I'm trying to think of which, I was on a field trip with Dr. Austin. So we went, I think it's Torrey Pines. I walked down from Torrey Pines, and you could see this. Now, it's kind of hard to pick up, because if you just see a cross section, like a cliff face, you'll see things like this, and you'll think they're ripple marks, that they're just long, linear, and they go back in there. But here, there were some drainage canyons or little gullies, down through the cliff. So you'd have this face, and then you'd have it cut this way. And so you could see this ripple mark. It wasn't a ripple mark. It should have been long and linear, but it was continued, as this bubble wrap pattern. And so that's the ones I've seen. Those were about that high. That's the one particular spot I've been to. I kind of wonder. I've been trying to get Austin interested in Florida geology for a long time. He's a good carbonate geologist, but he's got so much out west that's fun that I haven't talked him into coming over yet. That would be enough. Now, I think I mentioned Gene Project, Rate Project, Gene Project. The other research initiative ICR is funding or acting as the main coordinator for is FAST, Flood Activated Sediment Transport. And so this hummocky cross stratification would be a good object of study. Bill, you may know, when was it that turbidites were first discovered? They had for a while, say in the early 1900s into the 1930s, and I think even into the 40s and so on, they saw unsorted, there'd be layers of rock, big rocks, little rocks, rock powder, all mixed together, different shapes, some of them still angular and so on. And so they were saying, well, this is obviously glacial till. And so when ice picks up rocks as it shovels through the ground, it'll pick up big rocks, little rocks, ground up rocks, anything. And then when the glacier melts back, you get this pile of miscellaneous sized rocks. And so the only thing geologists knew about before was if you saw a layer of miscellaneous, missized, mismatched rock, it was probably glacial till. Well, they were having glaciers on the equator and things like that, and that, generated this idea of poles switching all over the place and stuff like that, which has run into, it's been falsified. But at any rate, then they found out, wait a minute, they started studying underwater landslides. Debris flows like the one that severed the transatlantic cables and things like that. And as they got better equipment for going deep in the ocean, they found out that turbidity currents, slurries that would flow underwater, density currents flowing down even 2% slopes would pick up rocks of all different sizes and drop them. And so then they came up with the name turbidite, and a lot of what was called tillites got renamed turbidites. And instead of being evidence of multiple glaciations millions of years apart, it really looked like fast, flood-activated sediment transport, rapid, broad-scale deposition. And so I think that there's some promising area of storm deposit research in this hummocky cross-stratification. Now, one reason you may have asked that, I may have to back off of that, what I just said a moment ago. If that's a storm deposit, a hypercane deposit, maybe I wouldn't really expect very many of those in lower Paleozoic rock and things like that. That the flood would be so massive and so all-encompassing around the world that you might not have that much generation of individual storms like that. So I might tend to think that they'd be found toward the top of the geologic column, more in the an indicator of post-flood deposition. So, now your question I didn't answer And his question, I told you I don't know the answer. And I gave you two conflicting answers. Isn't it cake time? Oh, okay. But boy, that's a good question. So I got to follow up on that. In Florida, I think I can see it somewhat, in the rock layers. But you need to do lots of boreholes and things like that geologists do. That I'd love to do. But yeah, I need to find out where geologically these are. That could be very helpful, yes.
How do you explain giantism in the post-flood world animal kingdom? Sloth, mammoths,
Yeah, I think the giants in the post-flood world are just the giants that existed in the pre-flood world that were on the ark. And what happened is the conditions after the flood, there were just an enormous number of environmental factors that all changed in ways that would be difficult to be especially difficult for the larger animals. And so I think that's kind of normal, is that they got off the ark. They were here, but they haven't survived to the present, with a few notable exceptions, like the Asian and the African elephant. And like I said, there might be the giant ground sloth still in some South American rainforests. There are occasional reports of an animal of course, there are occasional reports of dinosaurs from remote areas. But the post-flood conditions, they survived, the megafauna survived on the ark, got off the ark, began to multiply and fill the earth, but didn't make it due to ordinary methods of extinction after that lack of food, overhunting, climate change, inhospitable environments, no nesting areas, et cetera, et cetera, et cetera. What's that? Well, now that's a thought, yeah. Their runt offspring might survive. That's an interesting thought. Usually you think, if you had a litter, some animal that had a litter, that the big one, would be the one to survive. But if it's the big one that needs food, and more food, and food's scarce and hard to come by, maybe the runt, has a better chance to survive and escape the eye of would-be predators, etc. Survival of the runtiest.